In this section, chapter 1.2, we're looking at applications that we talked about in class. So our first objective is to solve a geometric problem. So in this problem, page 121 it's problem number 19, a contractor must tile a rectangular kitchen that is 4 feet longer than it's wide, and the perimeter of the kitchen is 48 feet. We want to note that in this geometric problem, we're going to use, since the perimeter was talked about, we're going to use this idea of perimeter. So I want to note that one of our strategies is going to use the formula, the perimeter is equal to twice the length plus twice the width. So we're going to find the dimensions of the kitchen first. That's part A. Part B is how many square feet of tile should be ordered if the contractor adds an additional 10%. Here we use the term area, and notice area is equal to length times width. And then finally we're going to determine the total costs if the costs are $12 a square foot and the sales tax is 6%. So in the first step, we're going to obviously draw our picture. So we're going to draw. And here's our dimensions. X is the width and x plus 4 is the length. We're going to use our formula, which is the perimeter is equal to twice the length plus the width. I just took the 2 out of both terms. And now I'm going to plug in the actual values. 48 is equal to twice parentheses the length, which is x plus 4 plus x. Well, we can divide both sides of the equation by 2 and we get 24 is equal to x plus 4 plus x, and we can subtract a 4 from the left side of the equation and we get 20 is equal to 2x, so x is equal to 10, and so our dimensions then of our kitchen is 10 feet by 14 feet. So the area in part B is going to be the length times the width, which is 14 feet times 10, and we get 140 feet. And 10% of that is 14, so we add that to 140, and our total area is 154 feet squared. Now our cost is the price plus the price times the tax. So our price is $12 per foot times 154 square feet. That comes out to $1,848. That's our price. So we take our price and we take that price and we multiply it by 0.6 and we add it, and our value is going to be $1,958.88. Our second objective is to solve money type problems. So on page 121 again, this is problem number 30. Ebony bought a 5-year Treasury note that paid the equivalent of 2.8% simple interest. She invested $5,000 more in a 10-year bond earning 3.6%, and that's $5,000 more than she invested in the Treasury note. If the total amount of interest from these investments was $5,300, determine the amount of principal for each investment. So in this case, we're going to use what we call a table. And at the top of the table, we have category, amount, rate, and interest. And then for the categories, we have the Treasury and we have the bond. So we're going to let the amount that she invested in the Treasury to be X, because the amount that she invested in the bond was X plus 5,000. The rate of interest was 0.028 for the Treasury, And for the bond, the 10-year bond, it was 0.036. So the interest is the amount times the rate, and it's 0.028 times x for the Treasury. For the bond, it's 0.036 times x plus 5,000. When I add the two interest rates for the two different funds, I should end up with $5,300. So that's what I did. I took this last column, and there it is. It's 0.28 times x plus 0.036 times x plus 5,000 is equal to 5,300. Now I distribute the 0.36 and I get 0.028 times x plus 0.036x plus 180 is equal to 5,300. And 0.064x is equal to 5,120. And we can see that x is 5,120 divided by 0.064. And of course we end up with 80,000 for our Treasury. And if we add 5,000 more, we'll get 85,000 for the bonds that she invested in. Objective 3 is to solve a motion problem. So on page 122, number 35, two passengers leave the airport at Kansas City, Missouri. One flies to Los Angeles, California in 3.4 hours, and the other flies in the opposite direction to New York in 2.4 hours. With the prevailing westerly winds, the speed of the plane to New York is 60 miles per hour faster than the speed of the plane to Los Angeles. If the total distance traveled by both planes is 2,464 miles, determine the average speed of each plane. Well, our strategy, of course, is the distance is equal to the rate times the time. And again, we create a table of information, our categories, our distance, our rate, and time. Notice that the top of our columns is nothing more than our math strategy. So the categories are to LA to New York in total. We have the distance. I have D1 is the distance to LA, D2 the distance to New York. The rate for going to LA is X, and for New York it's X plus 60 because that's what it said in the problem. The time to LA was 3.4 hours, and the time to New York was 2.4 hours. So we end up with two formulas from our columns. D1 is equal to the rate times the time, or the time times the rate. In this case it's 3.4x. And for New York it's D2 is equal to 2.4 times x plus 60. Now we notice from the total column we get D1 plus D2 is equal to 2464. So we just plug in the numbers for D1 and D2 into the formula, and we get this portion of the formula after we plug it in. You will notice that we end up from here down here to 3.4x plus 2.4x plus 144 is equal to 2464. And we combine like terms. We get 0.58 is equal to 2340. Why? Because we subtract 144 from both sides of the equation. Now we divide 2340 by 5.8, and we get x is equal to 400 miles per hour. So that is the rate going to LA, and the rate going to New York is 460 miles per hour. Our last problem that we're presenting in class is a mixture problem. We're going to look at page 121, number 32. A nurse mixes 60 cc's of a 50% saline solution with a 10% saline solution to produce a 25% saline solution. How much of the 10% solution should he use? Well, again, we set up a table. We have categories, volume, concentration, and pure saline are our columns. And you'll notice that the categories are 50%, 10%, and 25%. The volume is 60 cc's for the 50% solution. X, we don't know how much we're going to produce for X, which is X. The total is X plus 60 because that's the final saline solution that we're producing. The concentrations are now put in decimal form, 0.5, 0.1, and 0.25. So if I want pure saline volume, 0.5 times 60 is going to be the 30 cc's. 10% is going to be 0.1x, and our total is 0.25 times x plus 60. So we get the following strategy in solving our problem. We see that when we add the two solutions together, the 50 and the 10%, we get 30 plus 0.1x is equal to the total is 0.25 times 60 plus x. Well, we do the distributive property on the right side of the equation, and you see that we have 30 plus 0.1x is equal to 15 plus 0.25x. And then we have 15. If we subtract 15 from both sides of the equation, we get 15. We subtract a 0.1 from both sides of the equation, and we get 0.25x minus 0.1x. That's going to give us 15 is equal to 0.15x. We divide 15 into 0.15, and guess what? We get 100 cc's. So we need to add 10%. The 10% solution is 100 cc's. We add it to the 60 cc's at 50%, and we get a 25% solution with 160 cc's. That concludes our problems that we're looking at in class. You also need to look at some work problems, work rate problems, and we will be working on a few of those in class as well as with the problem sets of the day.